Alright, here are 20 practice problems on probability, which I also like to refer as the easiest section in the entire math SAT that you can't use Desmos for. Because to solve probability questions, all you need to know how to do is think and read the question. Now, I know that seems pretty obvious, like, of course you have to know how to think, or else, like, how would you solve it? No, but actually, you only need common sense to solve these problems. So of course I will link these problems as well as the answer key in the description, but I will go through every single problem as usual. So let's get started with question number 1. Now the thing for probability questions is that these first few sentences, you can basically just ignore them because all they're doing is explaining what you already see in the table. So instead of reading all of this and getting confused, just look at the table, right? Now the only important part that you do want to read in a probability question is usually going to be the question that, well, the sentence that has the question or a sentence that includes the given. So those are going to be your two important pieces of information that you need to get from the entire question. Other than that, everything else is pretty unimportant. So I'm gonna just go ahead and blur that out because we don't need to know any of that. Now let's get started. If a contestant is selected at random, what is the probability that the selected contestant received a score of 5 on day 2 or 3, given that the contestant received a score of 5 on one of the 3 days? So there's two important pieces of information that we need to know here. The first one is that the contestant must have received a score of 5 on one of the 3 days. So if we look at our table right here, this entire column has contestants that received scores of 5. So that's all we're going to need to be focusing on. Just this singular column right here. All of these other columns, we can just basically ignore. Pretend they're not there, just like this top part of the question. Alright, now our second piece of information is that they needed to receive a score of 5 on day 2 or day 3. So now we know that we don't care about day 1 anymore. All we need is day 2 or day 3. So I'm gonna just go ahead and pull this circle down. That is all the information that we're going to need to solve this problem. Now, if you don't remember how to set up like a probability fraction, because all your answers will be in fractions, unless you like want to put in decimal, which is weird. But anyways, in a fraction, so your fraction is gonna look like this, where x is over y. X, or your top number or your numerator, that's gonna be like the number of the things you want. So in this in this question, it's going to be the number of contestants that received a score of 5 on day 2 or day 3. That's what your top number is going to be. And then you have your bottom number or your denominator, and that's just going to be the total. So in this question, it's going to be the number of contestants that received a score of 5 on one of the 3 days. And if we look at our table now, let's go ahead and put that information in. So our total number of contestants, it literally says right here, the total is 7. So 7 is going to go on the bottom. And now the number of contestants that received a score of 5 on day 2 or day 3, that's going to be 2 and 3. So all I have to do is add that up. 2 plus 3 is equal to 5. And that's what's going to go on top of our fraction. So our answer is 5 over 7. Question number 2. The table above shows, I'm going to just stop right there. We don't care what it's describing about the table. I mean, we have our own eyes. We can see what the table is. So no need to be reading all of that. Let's move on to our actual question now. If one of the cars listed for sale is selected at random, what is the probability that the car selected will be a hybrid car priced at no more than $25,000? So there's actually three pieces of information that we're going to be getting from this very last sentence. The first thing is that it's going to be one of the cars listed for sale selected at random. Now that information is going to be our y, or it's going to be our bottom piece of information, or our total. It might not make a lot of sense right now, but let's just keep moving on. Then they want the probability that the car selected will be a hybrid car priced at no more than $25,000. So that's going to be our x, or our top number. First things first, I'm going to go ahead and find our x. So we want a hybrid car, so I can ignore this non-hybrid row. Then I want it priced at no more than $25,000. So this price greater than $25,000 column, I can go ahead and ignore that. Now, if we look, our answer is going to be 2. So 2 is going to be our top number, or, well, the number of hybrid cars priced at no more than $25,000. Now, this is where I feel like a lot of people might trip up or mess up, because I low-key did mess up here too. Anyways, it's gonna be finding that denominator or that bottom number. Now, the thing is, since we already went and crossed all of this stuff out, you would think that, oh, the total, which is 7 here, that's just gonna be our bottom number. So B is our answer. But that's actually not the case. You see, the bottom number is actually going to be the cars listed for sale. Now, what does this mean? This means it's going to be all of the cars listed for sale. I don't know why that 2 teleported over. Anyways, it's going to be all of the cars listed for sale. This includes both the cars that are priced at no more than $25,000 and the cars that are priced greater than $25,000. Basically, all that yapping was just to say that our bottom number is going to be 14. 2 over 14 reduced, that's just going to be 1 over 7. So our answer is going to be A. Now, I'm not gonna lie, I think this question is actually harder than the previous question, even though this one is only medium difficulty, and the last question was hard difficulty. And that's because a lot of people might mess up on the part right here where they're not reading closely enough to see that it's going to be any of the cars listed for sale. It never said that it's just going to be the cars that are no more than $25,000. So, when you're reading these types of questions, once again, be very, very careful. But as long as you know how to read and think, then hey look, you can get through the rest of them no problem. Question number 3. This is gonna be an actual representation of easy probability questions, alright? I don't know who let this medium difficulty be in the same category as this one, but anyways, let's get started with the question. So, we really only care about this question right here, just talking about what they found, alright? Like, I can just look at the table for that, so don't care about that. Oh, and right here, summarizing the table above. Okay, bro, like, then what was all that talking for about? Anyways, what fraction of the chocolate-colored kittens has deep blue eyes? So once again, 2 pieces of information we need to know. We want the fraction of chocolate-colored kittens. That's going to be our y. So the chocolate-colored kittens, that's going to be our y. And then the kittens that have deep blue eyes, that's going to be our x. So let's move on to our table now. First things first, we only care about chocolate-colored kittens. We do not care about cream tortoiseshells or even the total. Then we want deep blue eyes. So we don't care about this light blue. Wait, oh wait, that literally says deep blue. Oh, what am I reading? Okay, anyways, we don't care about the light brown. So, once again, deep blue eyes, that's gonna be our x, and that's 12. And then chocolate colored kittens, that's gonna be right here, or like total all chocolate colored kittens, which is 16. So our answer is 12 over 16, and if we look at our answer choices, we don't need to simplify that. So our answer is just going to be D. Oh, that one was nice and easy, man. Like, once you got rid of all of that, your 2 answers were right there. Okay? Unlike this one, where you had to actually find out that it was... Anyways, that I don't want to think about that question anymore. The answer is D. Question number 4. So, here we have a whole bunch of babbling, but this is the math section, not the reading section, so I'm not reading none of that. Okay? So, once again, it's really just a sentence with the question mark, so let's start reading. If one of these people who is rhesus negative is chosen at random, the probability that the person has blood type B is 1 over 9. What is the value of X? Alright, so they just gave you a whole bunch of information, like rhesus negative, and then we have a probability of blood type B, and then we want to find X? Like, what? So let's just take this step by step. First things first, we know that they are rhesus negative, so we only care about this rhesus negative row. We don't care about these positive people. Next things out, we know that the probability that the person has blood type B is 1 over 9. Now if you remember, our probability fraction, x over y, our numerator, that's going to be the number of like things that we want, and then the denominator is going to be the total. So for the case of this fraction right here, 1 over 9, 1 is going to be the number of people that have blood type B, and then 9 is going to be the number of people that are rhesus negative, or our total. Now that we know that, we can also set up another probability fraction in this table, or with information from this table. So first things first, the number of people that have blood type B is 2, and we're just going to put y for our total. Now we know that this ratio is also going to be equal to this ratio, 1 over 9. Now you just ask yourself, how do I go from 1 to 2? So, multiply by 2, what? And how to get from 9 to y? Well, I mean, what you do on the top, you do the bottom, so you also have to multiply by 2. So you know our ratio is going to be 2 over 18, with 18 being our total. Why am I starting to write now? Oops. And then 2 being the number of blood type B. Now we're not actually done yet, because this is our total, but they want x. So all we have to do is just subtract everything. I mean, 18 minus 7 minus 2 minus 1. What the? That looks like another 2. But that's just 18 minus 10 equals 8. So x is equal to 8. Hooray! Alright, so that was the way that I solved question number 4, but there is another way that gets you to the answer, and this one is gonna be, I guess, a little more faster, just because with the other method, you might think that 18 is the answer, when in reality, that's just the total and not x. But I'm gonna show you the other way. So first things first, I'm gonna go ahead and block all that out, because I don't like looking at words. And of course, we know that this is our ratio, so I'm gonna just set it equals to 1 over 9. And same thing, 2 over, but instead of substituting our total for y, we just know that the total is just all of these numbers added together. So just 7 plus 2 plus 1, which is 10, plus x. Now you can just cross multiply and find that x is equal to 8. Or another way you could do it is just using your brain, I guess. And of course, since we know that x is equal to 8, 10 plus 8 is 18, and 2 over 18 simplifies to 1 over 9. So that last method, of course, requires you to think a little bit more, because now you're asking yourself, 10 plus what would make this fraction reduce down to 1 over 9? Now, regardless of which method you decide to use, it doesn't matter, because they all still get you the right answer. Well, I guess besides that first one, because once again, you might think that 18 is the answer, but anyways, all of them still get you the right answer. They're also relatively quick, especially if you cross multiply, you can just put that in decimals. I still don't like that method, but it doesn't matter. Whichever one you're more comfortable with, then just do that one. Question number 5. The table below shows we don't care about any of that. If one of these state parks is selected at random, what is the probability that it has camping facilities but does not have bicycle paths? So, two pieces of information. It needs to have camping facilities, so this bottom row we don't care about. And it does not have bicycle paths, so this first column we also don't care about. We're left with the number 5, so that's going to be our number on top. Now our total, it just says one of these state parks, so that basically means it includes all of these, regardless of whether it has camping facilities or bike paths, whatever. So all we have to do is add all these numbers up. 8 plus 4 is 12, plus 20 is 32, plus 5 is 37. Our fraction is 5 over 37, so our answer is A. Question number 6. There isn't a table this time, so we should probably read the entire thing, because there won't be like any information describing a table, because once again, there's no table. Anyways, in a bag, there are 7 red, 4 white, 33 blue, and 33 yellow cubes. If one of these cubes is selected at random, what is the probability of selecting a cube that is neither blue nor yellow? So first things first, we want a cube that is neither blue nor yellow. So I think what we should do first is figure out the total. 33 plus 33 is 66, plus 4 is 70, plus 7 is 77. So our bottom number is 77. Now we want a cube that is neither blue nor yellow, so that's just going to be red and white cubes. 7 plus 4 is 11. Now there's no 11 over 77, so all we have to do is simplify this down, and that's going to be 1 over 7. So our answer is D. Question number 7. Once again, no table. Each vertex of a 14-sided polygon is labeled with one of the 14 letters A through N, with a different letter at each vertex. If one vertex is selected at random, what is the probability that the letter D will be selected will be at the selected vertex. This one is so unbelievably easy. Like, I don't know how this one is medium difficulty, especially with number 2. I'm bringing number 2 back. Anyways, letter D. How many times is there letter D in the letters A through N? The answer is once, alright? And how many total letters do we have? 14. So it's literally just once. 1 over 14. Question number 8. I'm gonna get rid of this. And then the table above shows I can get rid of that. And I'm gonna stop right here. For the survey, the number of email responses was twice the number of phone responses. If a person who preferred a picnic is selected at random, what is the probability that the person responded by email? Now this time there is going to be 3 important things that we need to know. The first thing is that the number of email responses was twice the number of phone responses. Now, had you not been paying close attention, you might have accidentally gotten rid of this. So, whenever you're choosing things to get rid of, I think anything before the table above shows or this detail shows or whatever, that's gonna be where you can stop. I mean, where you can get rid of, but after that, just stop. All this means here is that we're gonna multiply all of these percentages, all of our email percentages by 2. Then we want a person who preferred a picnic. So, pool parties, don't care about. Dinner dance, football games, don't care about that either. And we want the probability that they responded by email. Now, had you accidentally gotten rid of this little sentence right here, you would have chosen 5 over 25. But of course, that's not our answer because we need to multiply our email by 2. So our real percentages is going to be 10% and 20%. Now that's just going to be 10 over 20 plus 10, which is 30. And that's going to simplify down to 1 over 3. Question number 9. What is this law pair? Okay. On May 10th, 2015, there were 83 million internet subscribers in Nigeria. The major internet providers, okay, I don't care about that. By September 30th, 2015, the number of internet subscribers in Nigeria had increased to 97 million. If an internet subscriber in Nigeria on September 30th, 2015 is selected at random, the probability that the person selected was an MTN subscriber is 0.43. There are 3 million MTN subscribers in Nigeria on September 30th, 2015. To the nearest integer, what is the value of... Oh my goodness, bro. All that reading just to say that? That is so easy. Oh my goodness. What do I read all that for? Okay. Whole bunch of babbling, whole bunch of words, whole bunch of dates and companies. But all you really need to get out of this is that there was 97 million people in September 30th, because they asked for September 30th. Then they asked how many million subscribers did MTN have. And we know that it's going to be 0.43, well, the probability at least. So all you have to do now is multiply 0.43 by 97 million. That's literally all you have to do. All that whole paragraph just to say that. Like this first sentence you didn't even need. No one cares about May 10th. All right, let me bust out the calculator real quick. 0.43, 0.43. Oh, and another important thing is that it says P million. All right. So I'm gonna just do 0.43 times 97, and that's gonna get me 41.71 million. Technically, right? Since they already included the million here, you don't need to like multiply by 97 million. Then they asked to the nearest integer, so we're just gonna round that up into 42. So P is going to equal to 42. Now be careful, do not put 42 million, because then if you were to substitute 42 in here, that would be 42 million million. Whereas if you just had 42 by itself, it would be 42 million. Question number 10 for a science project. Alright, I don't care. Here we go. If one of the days on which there was no rain is selected at random, what is the probability that the day was a weekend day? 2 things we need to know. It's gonna be on a no rain day, so don't care about this. Don't care about this either. Then they want the probability that it was a weekend day, so don't care about the weekend days. Or the weekdays, sorry. Oh my goodness, so many days are tripping me up. Anyways, we have 16. That's gonna be our top. Then we have our total, which is 64. That's our bottom. Simplify that down. 1 over 4. Our answer is B. Question number 11. The table summarizes, don't care. One of these participants will be selected at random. What is the probability of selecting a participant from group A given, oh shoot, we finally get another given, that the participant is at least 10 years of age? Alright, first thing, we always gonna do the given first. At least 10 years of age, so we don't care about 0 to 9, and we don't care about the total. Now, we want the probability of selecting our participant from group A. So that's gonna be group A. Where's group A? Oh my goodness, I cannot see where I'm looking. Right here. This is group A. So 14 plus 9, that is 23. So 23 is gonna be our top number. Now, our bottom number or our total, they want that the participant is at least 10 years of age. They don't care if they're in group B, group C, or group A, which means all we're gonna be doing is adding the total. So 30 plus 30, that's gonna be 60. Our answer is 23 over 60. Now, whenever you have these questions that include the given, you always want to do the given like first, like when you eliminate stuff, eliminate the given stuff first. Question number 12. At a conference, there are a total of 275 attendees. Each attendee is blah 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 blah. If one of these attendees is selected at random, the probability of selecting an attendee who is assigned to group A is 0.44. And the probability of selecting an attendee who is assigned to group B is 0.24. How many attendees are assigned to group C? Now, straight off the bat, I can think of two ways to do this, but I will need a calculator, so let me pull up Desmos real quick. Alright, so here I am on Desmos, and the first way you can do it is just add up the probabilities. We know a probability is a fraction, so it's all just going to equal 1 in the end. So 0.44 plus 0.24, that's 0.68. Then 1 minus 0.68. The probability of getting assigned to group C is 0.32. Now all we have to do is multiply that number by 275, which is our total. 275 times 0.32 is 88. So there will be 88 attendees. Now another way you can do it is just multiply it out for each group and then subtract it from the total. What do I mean by that? 275 times 0.44, 121 people in group A. 275 times 0.24, 66 people in group B. Now I'm just add these two up and subtract that from 275, and we'll still get that our answer is 88 people in group C. Question number 13. If 1,200 customers register for new accounts at a social media website every day, what fraction of the first 60,000 new accounts are registered in the first 5 days? Is this for a probability? What? Okay, anyways, we have 1,200 customers every day. Then they want what fraction of 60,000 in the first 5 days. So let's find how many accounts were registered in the first 5 days. All we gotta do, 1,200 times 5, that's just gonna be 6,000. And then we want the fraction of that out of 60,000, so that's just 6,000 over 60,000, which is gonna simplify down to 1 over 10. And our answer is B. Yeah, I don't think that's probability, but I'm not complaining. I like easy questions. Question number 14. Whole bunch of babbling. Oh, how interesting. Ages of presidents. I got plenty of things to say about this, but maybe I shouldn't bring politics into this. Anyways, of those presidents who were at least 50 years old when they first took office, what fraction were at least 60 years old? So we have two pieces of information we need to know here. Of those presidents who were at least 50 years old, so that's going to be our bottom number or our denominator. And then we want the fraction that were at least 60 years old. So that is our numerator or our top number. First things first, we have to find those who are at least 50 years old. So those two don't care about. Then we want those who were at least 60 years old. So these two. 7 plus 3, that is 10. Over all of these, which is, give me a second, 20, 31, 34, 10 over 34. So our answer is B. Question number 15. Oh, don't care about that. To the nearest tenth of a percent, what percent of states with a state-level sales tax do not have a state-level income tax? Huh? Wait, let me. To the nearest tenth of a percent, what percent of states with a state-level sales tax do not have it? Huh? Alright, I'm not gonna lie, I didn't understand a single thing I just read, but let's see if we can cross some things out in the table. Okay. So percent of states with the state-level sales tax. Okay. So we want state level sales tax. This one has no, so I think I'm gonna cross that out. Then they want do not have a state level income tax. Okay, so we want this. So I don't care about that. Alright, so our top number is going to be 6, and that's going to be over. They want with the state level sales tax. So it's just going to be these two numbers. We don't care about this one. So 6 plus 39 is 45. And 6 over 45 is, give me a second. 0.133. Okay. So nearest 10. So that's gonna be what? If it's 0.1333, that's 13.3%. So our answer is C. Now I'm not gonna lie, I didn't understand a single thing I read, but just with what you got from here, you can just start crossing things out in the table, and then you'll be able to get the answer just fine. Question number 16. Shown in the table above. Okay. Which type of penguin has a female population that is closely to be a third of the total female penguin population in the exhibit? Wow, I cannot read. Okay, so we want penguin that has a female population that is a third of the total female penguin population. Once again, how's this probability? This is just like fractions and stuff. Anyways, we only care about the female population, so don't care about these guys. And then we want to be a third of the total. So let me find what the total is. It's 320. Alright. So I don't care. Oh wait, total of the female population. Okay. So I'm not including the men. I'm just talking about that number. Whoopsies. Alright, so don't care about that row. Now all you're gonna do is start putting these numbers into fractions, like 59 over 180, 27 over 180, and see which one's gonna be 1/3. So I'm gonna go ahead and pull up Desmos real quick. Alright, here is Desmos, and I'm gonna start putting this in. So 59 over 180. Wait, 59. Gonna click the fraction. Oh shoot, wait, what? Okay, I mean like that's pretty close to being 0.333, so I'm feeling chin strap right now. I wanna keep going though. 27 over 180? 0.15? No. 57, 54 over 180. Oh, that's 0.3 flat. Okay, but like this one's closer to 0.33. And then 40 over 180. That is 0.222. So our answer is gonna be this one. Chin strap, right? Chin strap, and just to check, 1 over 3 is 0.333. Yeah, I think that one's the closest. So our answer is A. Alright, I can't believe I messed this up. I just realized such another easy way to do this. Like, a third of the total female penguin population, right? All you have to do is take a third of the total. So 1/3 times 180, that's 60. Which one of these is closer to 60? Chin strap. Man, what am I doing going through each one, man? I could have just done that. Anyways, once again, you know, like, don't matter which way you do, right? Like, whatever way works for you, you know what I'm saying? Or am I just coping? Question number 17. A box contains 13 red pens and 37 blue pens. If one of these pens is selected at random, what is the probability of selecting a red pen? What? Oh, okay, anyways. So, probability of selecting a red pen, we have 13 red pens, that's on top. Then we want one of these pens selected at random. That means we're gonna include all of them, but of course, what else would you include? 37 plus 13, that should be 50, I hope. So 13 over 50, wow, so easy, man. I'm about to bring up question number 2, but anyways, 13 over 50. Question number 18, the table above shows, that's cool, but I don't care. Okay. A person from one of these departments is to be chosen at random. Okay, probably should delete that one too. If the person chosen works in the human resources department, what is the probability that the highest level of education the person completed is a master's degree? First things first, human resources department, don't care about counting. Then we want for them to be a master's degree. So that's going to be 2 over a total of 2 plus 4, which is 6. which is 1 over 3. Our answer is B. Question number 19. We can go ahead and ignore that. If one of these tiles is selected at random, what is the probability of selecting a red tile? Now I do notice we have two shapes here, but they never said anything about shapes, so we're just going to include the both of them. So I have the number of red tiles here, 30, over our total, 100. Simplify that down over 2, 3 over 10, and that's going to be our answer. Question number 20, the very last one. Ignore all that. If a caller last Monday who asked about his or her bill is selected at random, which of the following is closest to the probability that the customer also asked for repairs? First things first, they asked about their bill, so I don't care about these people who didn't. And then they also asked for repairs, so I don't care about these people who didn't again. That means that our top number is going to be 48. And that's going to be over. Asked about their bill is selected at random, so we won't care about the total number of people who asked for their bill. 671. 48 over 671. Man, why did I swap the decimals? Okay, hold on. 48 over 671. Okay, that's 0.07, which is B. Alright, that was 20 questions on probability. And if you notice, most of them are going to be so easy. Like, the hardest thing about this is going to be the reading, alright? That's going to be the most crucial stuff, because if you misread something, like, what was that one question? I already forgot. The one with, like, the emails, I think. Yeah, like right here, where you forgot, if you missed the email responses was twice the number, or if you missed number 2, I hate number 2, but one of the cards listed for sale, then that's where you're gonna mess up. But otherwise, if you read it really closely, follow it to the T, eliminate everything, and get your numbers, set up that fraction, it's gonna be so easy. Probability is so easy. Alright, well, that's gonna be all for probability, and I'll see ya.